Okay, so do you have any doubt till this part?
No, sir.
Okay, let me give you a question related to this part. If water is filled up to this point, in which a body in shape of cube is placed like this, its side is 10 centimeter, in which 3 centimeter is out of this water. Density of this particular object is 0.6 gram per centimeter cube. Density of water, 1 gram per centimeter cube. This object is in the form of cube. Find weight of object and bound force. Try to solve using the above part.
Okay, sir.
Take the value of gravity to be 10.
Yes, sir. I have taken gravity.
Write each quantity in terms of their SI unit.
Okay, sir.
Let me define you. Suppose if you have to calculate weight, so weight equals to simply mass times gravity, or we can transform mass in terms of density. So it will be sigma into volume times gravity. Sigma is 0.6 gram per centimeter cube. So to convert it in terms of kg per meter cube, just multiply it by 10 to the power 3. Volume of cube or total volume of cube, it will be side cube. So 10 divided by 100 cube times gravity, which is 10. So if you simplify it, this 0 and this 0 will cancel out. So it will be 0.6 into 10 to the power 3 divided by 10 to the power 3 multiplied by 10. So on solving, you will get 6 Newton. Ifra, is it clear?
Yes, sir. I thought that we have to take the volume which is in water, so I subtracted 3 from 10.
I have given the side of this particular cube, which is 10 centimeter, from which only 3 centimeter part is in air, the rest of the 7 centimeter is in water. It means, suppose if you define in terms of cube, it will be 3-dimensional, like this. So up to this level, similarly up to this level is in water. So its height will be 7 centimeter, length will be 10, and breadth will be 10. Okay.
Yes, sir.
So you can find buoyant force equals to density of water, that is 1 into 10 to the power 3, volume of object immersed into it. So length is 10 centimeter, breadth is also 10 centimeter, but up to 7 centimeter height, it is immersed into it. So it will be 7 by 100. Gravity is 10. Okay.
Yes, sir.
So if you simplify it, you will get 7 Newton. Is it clear?
Yes, sir.
Done.
Just a minute. Done, sir.
So if you equate these two terms, weight of object and buoyant force, let me define another expression. If weight of object equals to buoyant force. So according to the formula, weight equals to sigma into volume times gravity. Buoyant force is rho, volume of object immersed times gravity. So gravity will cancel out. So volume immersed by total volume equals to sigma divided by rho. Now, we may define this particular fraction in 3 different ways. First, if volume immersed is smaller as compared to total volume of object, it means there is partially immersion of object in liquid. So this particular fraction will become less than 1. So you will say density of object will be less than density of medium. Is it clear?
Yes, sir.
So in this case, object will behave like this. This immersed volume is lesser as compared to its total volume immersed. So it is the case of floating. Similarly, Volume of object immersed equals to total volume. It means sigma and rho will become equal to each other. In this part, object will behave like this, completely immersed, but still floating. In third part, suppose inside volume becomes slightly greater as compared to outside or total part. It means sigma will become greater than rho. It means object will sink to this point. So in both first and second part, object is floating. In this third part, object has got sink. So this is called floating or flotation, and this is the case of sink. So you'll be asked, define condition under which object will still floating in a particular liquid. So you'll say law of flotation or floating condition. Volume of object immersed divided by total volume, or it is equals to sigma by rho. This particular ratio would be less than equal to 1. Or you can say buoyant force and weight. Just 1 minute. Weight of object is less than equal to buoyant force. Is it clear?
Yes, sir.
Just write it down.
Done, sir.
Now there will be another term that is called apparent weight. In the case of flotation, buoyant force always equals to weight. So net weight experienced in the case of flotation will be 0. So apparent weight in case of flotation will be 0. In case of sinking, weight apparent equals to actual weight of object minus buoyant force. Actual weight is sigma volume gravity. Buoyant force is volume of object immersed times gravity. If it is case of sink, so volume immersed and volume of total object will be equal to each other. So just put the value of V immersed to be V times gravity. Take out rho Bg to be common. So you're left with 1 minus rho by sigma. This particular part is nothing but mass times gravity. So we may write it as mass times gravity 1 minus rho divided by sigma, which is also equals to weight of object in air. Now from this part, if we divide this term by mass, you will get net acceleration of object in this fluid. It will be gravity times 1 by this part. Is it clear?
Yes, sir.
Okay.
Done, sir.
Using this concept, let me define your question. Suppose a body is dropped into bath of liquid from this height. Let density of this particular object is sigma and density of this particular medium is rho, in which sigma is less than rho. Height of this object is h. So you'll be asked, find maximum depth it may sink. Let me give you some hint how we'll approach this. Just see, this particular object is initially at this point. So what would be its initial velocity at this state?
So 0.
Good. So initially its velocity will be 0. On reaching to this particular surface of liquid, it may have acquired some of velocity, let's say v1, on falling down under the effect of gravity. So we may find the value of v1 using third equation of motion. Okay.
Yes.
Now in this particular fluid part, it will be experiencing downward force due to weight, upward force due to buoyant force. Which of these forces will be stronger, buoyant force or weight?
Sir, wait.
Since density of object is small as compared to density of liquid, it means buoyant force will be stronger. Okay. Otherwise, if weight will be stronger as compared to this buoyant force, it may sink to hit this particular surface. Okay.
Yes.
So from this, we can find net force acting on this particular body in this viscous medium. So F net equals to buoyant force minus weight of object. Now, we can write this buoyant force as density, volume, gravity minus density, volume, gravity. Take out sigma Vg to be common. So you're left with rho by sigma minus 1. This will be nothing but mass times gravity. So if divide this term by m, you'll get net acceleration equals to gravity times rho by sigma minus 1. It means this body will experience this amount of retardation in this viscous medium. So it may fall to this depth at which its velocity or final velocity will become 0. Total depth from this point to this point will be d. Just use third equation of motion and take this particular acceleration to be negative or retarding and simplify it for d.
Okay.
Is try to solve. Ifra, any doubt? On falling through height h under the effect of gravity, it will be v1 square equals to u square plus of 2gh. Now in viscous medium, v square equals to u square minus of 2as, where a will be minus 1 times d. This term is 0. Put the value of v1 square to be this and simplify it. So you'll get 2gh equals to 2 times g bracket rho by sigma minus 1 times d. 2g and 2g will cancel out. So d will equals to h divided by rho by sigma minus 1. You got this result?
Yes, sir, I did somewhere mistakes, so it was a bit different now.
Okay. Is it clear?
Yes.
You have
Done,
written?
sir.
Okay. Now, similarly, next problem related to this part. There was a question in NEET 2016. Suppose you have container in which two different types of liquid is filled. One is n times rho and the other is rho. If a rod is immersed into it, having length L, whose K times L is in denser medium. So question is to find density of rod. First tell me, Ifra,
Yes, sir.
what are the forces that is acting on this particular object at this condition?
So buoyant forces acting and it's weighting acting downward.
So how many buoyant forces are there?
So from downwards,
Since we have two different types of liquid, so there will be two different types of buoyant force acting on this object, and always act opposite to the gravity, so in upward direction. So net force acting on this object will be buoyant force due to first liquid, buoyant force due to second liquid, and these two forces will cancelling out the effect of weight. Okay.
yes, sir.
Now put the value of each term related to this and simplify it to find density of object.
Okay, sir.
Ifra, any problem? There will be K in this particular expression as well. If I just 1 minute. Just see, let me solve this particular part. Buoyant force in first liquid, that is the lower part, density of liquid times volume of object immersed. Let's say area of this particular rod is A. So volume in this lower part will be equals to area of base into height times gravity. Similarly, in second liquid, density of liquid times volume of object immersed. So it will be total length minus K times L times gravity. Weight of object is sigma, total volume times gravity. Ifra, is it clear?
Yes, sir.
Now just simplify this particular part. Rho, A, L, and G. No. A, L, and G will cancel out. So you're left with N times rho into K as first part. Rho times 1 minus K and second part equals to just sigma. Take out rho to be common. So you're left with N times K plus 1 minus K equals to sigma. We may write it as rho 1 plus K times N minus 1 equals to sigma. So this will be our final expression of density of object. Is it clear?
Yes, sir.
Just write it down.
Done, sir.
If iceberg of 25 liters is in water, find volume of it remain in air if density of ice is 0.9 gram per centimeter cube. So for these type of problem, when there will be floating with some portion in air and some portion in water, just use volume of object immersed divided by total volume equals to sigma divided by rho. Okay. So
Okay,
we
sir.
have sigma, we have rho, we have total volume of object. So we can find volume of object immersed in this particular water. So if you subtract it from total volume, you will get volume of object that will remain air. Okay.
Okay, sir.
Ifra, just check your calculation.
Okay.
Volume of object emerge equals to total volume 25 sigma of object 0.9, density of water 1. So 25 into 9, it will be 22.5 liter. So volume of object remain outside, it will be total volume minus 22.5. So on subtracting, it will be just 2.5 liter. You got this or something else?
Yes, sir, I have done mistake in subtracting to 25 from.
Okay, okay. So is it clear to this part?
Yes, sir.
Let me give you a last. There was a question in IIT. Suppose from spring measuring balance, a body A is hanged to measure its weight. Similarly, a pan containing liquid is placed over another measuring tool B. This is spring balance, let's say A, which is measuring the mass of or weight of this particular block, which is hanged freely under the effect of gravity. Now suppose liquid in a pan is placed over another measuring tool B. Is it clear?
Yes, sir.
Now question is, if this particular block is immersed into this particular liquid, it means like this. So you'll be asked how the reading of A and B be affected. Reading of A will increase or decrease. Reading of B will increase or decrease.
The reading of A will decrease and reading of B will increase.
Good. Why it would be?
So because on A, bound force will be acting, and because it is half sink, so there will be
No,
some.
it's completely sink. This object is completely sink in this particular liquid. Your answer is correct.
Yes, so then also from weight, some bound force will be acting because the density of the body will be more than the density of water.
Let me define you this part. This object is initially experiencing a downward force due to its own weight, mg, but now, due to some burn force, since it has decreased some liquid, So it must be experiencing some upward buoyant force. So net weight or net force will be mg minus buoyant force, which will be lesser as compared to its initial part, that was mg. Similarly, in second part, in the case of liquid, initially there will be mass of liquid only. So there will be only force in downward direction, that will be mg. But now in this part, there will be force of on liquid plus, since liquid exerts some buoyant force on this particular block, so block in turn will give reaction to this liquid. So there will be another force exerted by this block in downward direction equal to buoyant force. Is it clear?
Yes, sir.
So net force in this case will be sum of these two terms. So you'll say the reading of B will increase and reading of A will decrease. Okay.
Okay, sir.
You have written?
And then, sir, yes.
So this is all about concept of Archimedes' principle of calculating buoyant force and weight and some related problems. Let me define you some interesting part, that is surface tension. To define this, let me give you some basic idea about molecular interaction. There will be two different types of molecular interaction. One is adhesive force and the other is cohesive force. You must have learned about these terms in your chemistry. Do you have any idea what do you mean by adhesive and cohesive?
So adhesive that attract towards each other, cohesive which separate from each.
No, both are attractive force. Adhesive means attraction between particles of different type. Attraction between particle of different type or different particle. Cohesive means force of attraction between similar particle. Force of attraction between similar particle. Is it clear?
Yes, sir.
Now, suppose you have container in which liquid is filled up to this point. Ifra, just tell me, what do you mean by surface tension? If you have any idea.
So the force on the topmost surface of the liquid.
Okay, which force? Okay, let me explain. Suppose if you consider a segment at its lower portion at this point. In this segment, there will be particle at center and there will be some neighboring from all sides, like this. So each particle will exert some cohesive force since all are similar to each other, like this. Is it clear?
Yes, sir.
So net force acting on the centralmost particle in this case will be 0. So F net on central particle will be 0. Now, suppose I have considered a segment at this point for this top surface. There will be particle that is at this surface, another neighboring particle, this. So all will exert cohesive force towards themselves like this. So if you calculate net force on this particular central particle in this case, will it be 0 or something else?
So it will not be 0.
Good. So we can say in this part, F net at central particle in this case will not be equals to 0. So we can say there will be always some force acting on this top layer particle due to its neighboring particle. This force will tend to become this particular surface as stretched membrane or get straightened membrane. This property of fluid is called surface tension. Is it clear?
Yes, sir.
So we may define surface tension as the top layer of liquid film. Liquid film means thin layer of liquid. Act as stretched membrane due to molecular interaction. This behavior of top layered liquid is called surface tension. Is it clear?
Yes, sir.
Now first write it down to this part.
Done, sir. Done, sir.
In general, surface tension acts tangentially to the interface of two separating medium. So let me define the surface tension in some other way also. Surface tension acts tangentially to the interface of two separating medium. Next, surface tension acts or surface tension of a particular liquid directly proportional to cohesive force. Greater the cohesive force of attraction between the particles, it will have greater value of surface tension. Inversely proportional to adhesive force. Inversely proportional to temperature. Surface tension also defines spreading tendency of a particular liquid over a surface. Spreading tendency of liquid over a particular surface. So smaller the value of surface tension, it can spread over more surface area. If surface tension is large, it can't spread over that particular surface. Is it clear?
Yes, sir.
Now, let me define you some physical phenomena related to this surface tension. So first question related to this part will be, why we prefer hot soup instead of cold? Any guess?
So because it will move.
Let me define you. You must have learned in some other earlier classes about tongue or taste bud on it. Okay. On our tongue, various taste buds present on different section of tongue. Okay. So
Yes,
if
sir.
temperature of that soup is large, it means for higher temperature, surface tension of liquid decreases. And if surface tension of liquid is small, it may spread to large surface area of tongue to get encountered or to get interacted with different taste bud, and hence it tastes much better. Okay,
Yes, sir.
so we can say on raising temperature, surface tension decreases, hence liquid can spread over more surface, so get interacted more taste buds, hence taste better. Is it clear?
Yes, sir.
Similarly, next question will be why we use detergents with water to wash clothes. Any idea?
So because it is also a fluid and it will spread over larger area than.
Detergent will act as impurity to that liquid. Okay.
Yes.
So on adding impurity to liquid decreases its surface tension. Hence, water will act to spread over dirt easily and cleanse it and to wash it. Is it clear?
Yes, sir.
So we can say on adding detergents decreases surface tension. So water will spread over dirt easily, hence can cleanse it and wash it easily. Just write it down till this part.
Okay, sir. Done, sir.
Now, on the basis of this surface tension, let me define you angle of contact. Suppose on a particular surface, if we drop water, so it may acquire this type of shape. In case of water. But if you drop mercury, it may acquire this type of shape. So on the basis of its geometry, we may define surface tension. Surface tension acts tangentially to the point of or to the interface of two separating medium. So let's say at this point, if you draw a tangent along this direction, so this particular tangent is separating two different medium. One is air and the other is liquid. So this surface tension is in between liquid and air. Is it clear?
Yes, sir.
Similarly, at this part, if you draw along this direction, this surface tension in between solid and air. And similarly, at this point, it will be in between liquid and solid. Is it clear?
Yes, sir.
Similarly, if you draw surface tension at this point, it will be along this direction, liquid and air, along this direction, solid and air, and along this direction, solid and liquid. So the angle in between these two surface tension, let's say theta, these two surface tension is theta, is called angle of contact. Is it clear?
Yes, sir.
So in this first part, theta is acute. In second part, theta is obtuse. In first part, water or particle of water having greater adhesive force to cling with particle of this particular surface and get spread out. So we can say adhesive force in this case is stronger as compared to cohesive force. Hence, surface tension of this liquid or water is small, so it can easily spread out. And hence it can wet the surface. But in second part, in case of mercury, theta is obtuse, so cohesive force will be stronger as compared to adhesive. Cohesive force increases the value of surface tension. So you can say surface tension of mercury is large, hence it can't spread over the surface. Hence it can't wet the surface. Ifra, is it clear?
Yes, sir.
Okay, just write it down.
Done, sir.
We've just completed the theoretical part of this surface tension. Let me define you how to calculate numerically the value of surface tension. So next is calculation of surface tension. Suppose a circular disc having hole at its center is placed over liquid. Like this. The radius of liquid or the radius of this inner surface is small r, and the radius of outer surface from this point to this point is capital R. So if you want to uplift this particular disk from the surface, first you need force equal to weight of this particular disk. Is it clear?
Yes, sir.
And next, since this particular disk or the particle of this particular disk is in contact with this liquid, so there will be some adhesive force in between them, which will tend to pull this disk back to its surface. So to overcome that, you must need some additional force to uplift it. Is it clear?
Yes.
So that extra force provided to this disk to uplift it per unit length of its interacting boundary is called surface tension. So from this we can conclude surface tension equals to force to overcome the interaction, to overcome the interaction divided by length of its interacting boundary is called surface tension. So for this disk, we have two length of its interacting boundary. One is from the inner part and the other is outer part. So T equals to force divided by inner length, it will be 2 pi r. Outer length, it will be 2 pi capital R. So if we take out common 2 pi, so it will be just r plus r in case of this hollow disk. Is it clear?
Yes, sir.
So from this, we can conclude SI unit of this surface tension will be force per unit length. So we can write Newton per meter, which is equivalent to spring constant or force constant. Okay,
Yes, sir.
Nabila, just join in 10 minutes. Okay. Similarly, we may define suppose you have a ring. So in this part, small r becomes capital R. So width becomes negligibly small. So if you put the value of small r to be capital R in this expression, you will get t equals to f divided by 2 pi r plus r, that is 2r. So it will be 4 pi r. Is it clear?
Yes, sir.
Now, if you break this particular surface to form as a rod, so for rod, 2 pi small r or 2 pi capital R will be L. So if you put in this above expression, L plus L will be 2L. So you'll get surface tension equals to F by 2 times of L. Is it clear?
Yes, sir.
Similarly, suppose you have complete disk. So in this part, small r will be 0. So if you put this in above expression, you will get t equals to F by 2 pi r only. Is it clear?
Yes, sir. Yes.
Just write it down.